Good morning, ladies and gentlemen. Welcome to Global Manufacturing and Supply Chain Execution Excellence Summit. It's edition 20. So, uh, welcome Mr. Faisal Ziauddin to the show. We'll spend a couple of minutes because it is the first topic. So, we'll try to spend few minutes, 2 minutes, 3 minutes, so people can join comfortably. So prior to that, I would like to give a quick briefing, ladies and gentlemen, across the globe. I would like to thank all the speakers who graciously accepted to give and share their knowledge, and the participants around 650 plus participants who registered, and some could be through YouTube and other channels. So the program is sponsored by FRUSI and Fru Strategy. The reason behind sponsorship for Global Manufacturing and Supply Chain Excellence Summit is we would like to connect industry experts to the organizations, as I repeatedly said in the last events. So there are so many unknown, or there are so many areas where organizations need help, and sometimes they don't know where to seek help. So we try to connect that. We try to bridge that gap by linking the experts to the industry community. So this way we learn a lot, and also we get connected with the people, and we understand what are the industry pain points and how can we solve. Okay, so this is how, and we are very particular about Indian community. The reason is we want to make India great and compete with the global powers like US and China and everybody else. Okay, so this makes this encourages us and gives energy to do these programs successfully again and again. So I would like to start. Let us start without delay. Our first session. I would like to introduce Mr. Faisal Ziauddin. Little, give me 1 minute. So, Mr. Faisal Ziauddin. So, first of all, thank you, Mr. Faisal, for joining the session today.
Same here, same.
Yeah, Mr. Faisal Ziauddin is talking about topic predictive maintenance strategies to maximize OEE and reduce downtime. It's a very important topic for manufacturing sector, especially in India and of course in any developing country. So, Mr. Faisal Ziauddin is an experienced operations advisor and lean manufacturing expert with extensive experience in global manufacturing. He specialized in helping MSMEs improve operational performance, enhance EBITDA, optimize supply chains, and drive sustainable growth through lean manufacturing, TPM, Six Sigma, and operational excellence. Having worked with leading organizations such as ABB, Thomas & Bells, and many more, he brings practical insights and proven strategies to transform manufacturing operations into high-performing businesses. So, with this, I request Mr. Faisal to take up this topic. So, the logistics for the event is you will have a 30 minutes session followed by 10 minutes Q&A. Please feel free to write your comments in LinkedIn and YouTube. So we will get those comments and we'll make sure that your questions get answered. Okay. So over to you, Mr. Faisal. Welcome and take it.
Thank you so much, Sheikh Kadir Shah, for having me. It's always a privilege to be part of RUSI and your programs. I may request the slides to come up to take it forward. Yeah.
You're sharing the screen?
Please
who is sharing the screen? Jyoti, you're sharing?
I will share it.
Okay. Okay, take your time. Yeah, we can see it. Yeah,
You can see it, yeah?
yeah, yeah, yeah.
Wonderful, wonderful.
Yeah, please take it up.
Yes. So like you said, predictive maintenance strategies for maximizing OE and reduce times. Yeah. It is a for manufacturing people. I think it is their daily bread and butter. So I thought, let me start on a lighter note and share with the audience here that predictive maintenance per se is the introvert in the maintenance world. Yeah, why do we say that? Because predictive maintenance basically watches the trends, listens to the vibrations, analyzes the data, and then very quietly tells us that such and such point, such and such bearing will be failing in such and such time. So the real magic is not predictive maintenance for that matter. The onus lies on the organization and the its people to listen to what is being said and take timely action. Meaning what? That the importance is in listening carefully when it comes to predictive maintenance. What has transpired over the years, we started with the premise that if something is not broken, let us not fix it, yeah, till it's fails. But then gradually we realized that the cost of downtime is always higher than the cost of prevention. So over a period of time, we started to invest in predictive maintenance and OEE per se. How did this all evolve? The need arose from the fact that from the if it is not broken to not fix it paradigm, which is the reactive part of it, some many decades ago we went into preventive maintenance. Still, lot of organization you see they are on this path of preventive maintenance, where the idea is to prevent the problems before they occur. The gap here remains is that sometime lot of useful life of the machine gets wasted because the preventive maintenance has happened a bit early. As if you look at the diagram number 2 under preventive maintenance, it highlights the wasted useful life here. So there was a need to predict problems to increase asset reliability and utilize the useful life to the extent possible. So this is where the need for predictive maintenance arose. The other part, which I thought, let me define it at the initial stage itself, is the overall equipment effectiveness, which primarily talks about a compass for value creation. It is not a metric to be measured. It is basically something to uh, get the insights and work diligently towards removing them, root causing them, getting your teams on board and solving the problems with assigned timelines. So what is OEE primarily? Primarily, OEE is a combination of availability, performance, and quality. When we talk about availability, a portion of time that a machine or process is actually running when it is planned to do so. Performance per se measures how often an equipment or process is operating at full capacity. Quality, let us take out what you produced in the shift minus all the defects that got produced during those 8 hours. What will impact the OEE for that matter? The OEE, if you look at it clockwise, starting from 0 to 3, 4, 5, 6, the first two are the breakdowns and the setup adjustments, which primarily lie under the availability losses. Remember, APQ. So they lie under the availability losses, where you have unplanned downtimes caused by technical defects, tooling failures, and mechanical malfunctions. You have setups and adjustments, planned downtime due to product changeovers, tooling changes, calibration, machine calibration delays. Then you have 3 and 4, which talks about small steps and reduce speeds. Frequent interruptions, sensor blockages, material jams, and operators, which operators have to resolve, reduce speeds, equipment running slower than its ideal theoretical cycle time. This is most of the time what the manufacturer or the OEM has mentioned. Organization prefer to move at say 80% of that capacities. Poor habits and poor material. So these all lead to reduced speeds. Then you have finally the Q part of it, the quality losses. Primarily, they fall under startup rejections and production rejections. I have worked about around 15 years in cable manufacturing. Now, every time in cable manufacturing, when you see a size change or a color change, you see issues where you will have tooling problems because the design department gave you a certain diameter for the cable to be manufactured, and the QC department is the one to provide the tooling. And there is always a mismatch between what is the design diameter and what is the tooling being provided, and that is where it becomes a trial and error thing. So you see losses happening there. On the starter rejection part, you will see a lot of PVC bleeding, color changes before you get the exact RAL number that is mentioned on the design sheets that is to be achieved for that particular design of cables. Then you have startup losses, yield losses or inconsistent output that occur during the initial machine warm up or startup period before optimal production conditions are reached. So these are primarily the six big losses which impact the OEE in real time. Now, once we understand the basic premise behind OEE and the six big losses that impact it, there is a need to build upon it, and the need to build upon comes once we create the loss tree. Now, the percentages may shown here may not add up, but the idea is very loud and clear that your availability, performance, and quality losses have to be further trickled down to see from where those are coming. And then, like the Pareto law says, 80/20, there is a need to prioritize these losses, find the root cause, assign owners, and verify the impact. I got this wonderful slide from Google while I was preparing, which basically depicts the entire philosophy of value creation and what is to be tackled and how does this impact the OEE. It talks about total time. It relates to that asset utilization, plant operating time, which is the big blue line in the middle, plant production time, which is the operating time minus the plant shutdown time. Operating time with the downtime losses becomes the availability, and operating time minus the speed losses become the performance. Fully productive time minus the quality losses, this becomes finally the overall equipment effectiveness. So it's an excellent way of visualizing OEE, and we can have our own uh, percentages assigned here for different type of losses to see that what is to be addressed on priority. Now, having talked about predictive maintenance and OEE, I thought, let me build up a baseline from my earlier experiences, that all of this primarily sits on getting your people ready. So I have spent some years with ABB and Graev, and like Sheikh Saab mentioned, with Thomas and Betts prior to that. Yeah, and how did we get along getting the people and the shop floor understand what is expected out of them? We started by creating live equipment life history, which means capturing what the OEM has said, what are the electrical, mechanical, and instrumentation breakdown that has happened over the years, what spare parts got replaced and when, who was the supplier. So all of this effort was put in by the concerned departments to create equipment life history. In some cases, these equipments may exceed 100 in number. In some cases, in some of my earlier organizations, this number was in excess of 200, 256 to be precise. And then we started setting out TPM. Now, ABB Graev, they already have a global benchmark for total productive maintenance and lean per se. They have global models for it. They call it Lean 101. And every time and anytime they build up a new plant, there is an extensive effort on part of the management and the plant teams to get the total productive maintenance rolled out, engage the plant personnel. So when you do that, you will have to train your people on autonomous maintenance. Yeah, you will have to tell them uh, about auto quality, which is no inspection from quality department. Everything that moves out of the machine is approved and accepted by the subsequent machine. It's in good quality. And one of the great learnings of this uh, setup was that most of these organizations had floating maintenance team leaders instead of having a dedicated mechanical engineer or an electrical engineer or an instrumentation crew. There was maybe a one or two floating high level maintenance team leaders who were equipped, trained, and knowledgeable about all the three aspects of maintenance, which is electrical, mechanical, and instrumentation. And the primary onus of machine maintenance was with the machine operators, for that matter. Every day there was a daily discipline inculcated in all the team members, that every day you come at 8 o'clock, you do your clit. Clit is the cleaning, lubrication, inspection, and tightening. Take around a 360 walk around the machine and see everything is in place, nothing is leaking, your bins are empty for the day, you are ready to go. So this task was like, the first 30 minutes of every shift. So this basically brought a sense of belonging, sense of ownership. And definitely when the plant management takes a walk around the Jamba, you will see that, and a sense of pride developing on the. Yeah, otherwise most of the people on the shop floor I've seen in my earlier organization sleepwalking on the shop floor. They don't know what is happening. They don't know what is in the Hyjanka. They don't know what is the job card to be done today, what is to be shipped today, what is the urgency. So that basically brings about a definite desire to be part of the organization. Now once you set, and this takes about what, when we did this Graef project, we brought in the people about a year before the actual plant operation began, and we had already trained them on autonomous maintenance, auto quality. And once we started rolling, we asked the operator levels down under, that what are the possible low hanging projects that we can initiate, yeah, where you can all come together. And especially not talking about capex, because capex projects are something one time, yeah, you put the money and you bring about a drastic improvement. but small incremental Kaizen improvements uh, will be enabled through such that was basically the idea. So we created cross-functional team, which is the setup CFT teams under team leaders, and assigned the HODs as the mentor. So what is the takeaway from this? The ability of the entire team, which may be 100, 200, 300 people. I have worked in plant which has 700 plus people, and recently my last assignment with a company called Zuari Industries, we were talking about 1,000 plus people. Yeah. So the task was to bring them together under cross-functional teams, uh, learning to see where the uh, problem is, what are the problems which can be solved without incurring heavy expenses, learning to work in teams, communicating across hierarchies, vertical, horizontal, learning to solve problems using tools such as PDCA, Pareto, and not limited to only this. Just to mention that they got introduced to these lean toolkit for that matter. I am not a great advocate for lean per se, yeah, because I still feel that there is a lot of industrial engineering to be done on,
Industrial.
on the shop floors before we really graduate into full time uh, educating and sharing knowledge on the lean and Six Sigma for that matter. And this all basically, what happens, this all brings in accountability and ownership and sense of belonging. And I think this will always remain, whatever technological interventions we bring it about, this will always remain the cornerstone of any MSMEs, manufacturing, or even any other industry for that matter. CII insights, let make a case for predictive maintenance. Yes, Indian manufacturing contributes 17% of its GDP, a big number. Indian companies can reduce maintenance overheads by up to 30%
Mhm.
following preventive and PD activities. Following correct maintenance activity, the life of the machine can be increased by 5 to 10%. And this is a surprising figure
Mhm.
that I found on on Google. 11% of machine assets fail because of age-related issues, and this is debatable. Maybe somebody in the organization can ask that where did you get this figure? So now, and the other part is even more alarming. The 89% fail because some of the other faults qualified as human error, premature environmental. Yeah,
Mhm.
because of excessive heat in my part of India, the handbrake rubber got melted. Yeah,
Mhm.
so this is something that will fall under environment for that matter, and some of that thing that we are having on the petrol front. The Energy and Resources Institute, TERI, opines that good maintenance practices can slow down energy consumption by 10 to 25%. And last but not the least, and we always seem to miss the safety aspect of all the interventions. Yeah, the National Safety Council confirms that 25% of workplace accidents happen due to equipment malfunctions. So this is basically to build up a case for predictive maintenance, and these are CII insights on the net. Typically, what a life of a machine looks like. There is a machine design. We bought a lot of machines from Nokia mainly for Portier, and when I was in cable manufacturing. Yeah,
Mhm.
and I have seen the second part of it, the precision maintenance part of it. That if the machine installations are not done, the alignment is not correct, you continue to tackle those breakdowns, those poor quality products. So this is basically prior to starting to manufacture, installation of the machine is extremely critical aspect which every organization needs to look into. Basic and the P2F, the potential and failure curve, is a very good indicator
Mhm.
and a baseline for predictive maintenance, which I'm elaborating further in the next slide. Yeah, basically, the PF curve plots time on the y-axis and the condition of an asset on the x-axis and the y-axis. The potential failure, this is the P part of it. This marks the point where potential failure can be detected using condition monitoring techniques. It
Mm.
might be vibration anomaly, unusual sound, or a temperature spike. The functional failure is the point where the equipment stops functioning as intended. It's breakdown or catastrophic failure that we want to avoid. The interval between P and F, known as the PF interval, is crucial. It basically represents the window of opportunity to take action and prevent a functional failure. So, what are the predictive maintenance technologies involved here? The PF interval 1 to 12 months ultrasound detection. Yeah, very early in the life cycle. Vibration detection 1 to 9 months. Oil analysis 1 to 6 months. Performance monitoring condition based 1 to 6 months. Thermographic detentions, yeah, 1 to 6 months. Audible noise detection 1 to 4 months. And finally, if it starts to heat up, the time has really come. Yeah, it's 1 to 5 days. Now, ultrasonic basically is l- listens for high frequency sound to identify compressed gas, air leaks, early stage bearing friction, electrical arcing. A vibration analysis, for that matter, measures mechanical movement to catch imbalances, misalignments, bearing and wear weeks before physical failure occurs. Oil analysis, for that matter, evaluates lubricant quality, detects microscopic metal wear particles to monitor internal wear and tear without disassembling, disassembling the machine. Thermal imaging uses infrared sensors to detect abnormal heat patterns, quickly spotting electrical resistance or friction issues. Maintenance ecosystem. Now, Sheikh Saab may
Yeah.
add here the MES part of it, the
Yeah.
manufacturing execution part of it, and then subsequently the ERP part of it. Yes. Now, these are the starting blocks, which is the Industrial Internet of Things, uh, SCADA, and the predictive maintenance, followed by the manufacturing execution. If you want to bring in the production planning part of it, and the warehousing and all of that, and
Mhm.
finally the ERP part of it, if you want to bring in the finance and all the cost accounting
Mhm.
part of it. Yes. So, SCADA, supervisory control and data acquisition. Think of them as layers in an industrial digital ecosystem rather than competing solutions. Yeah, basically the IoT talks about connectivity, real-time data, sensor data, SCADA, dashboards, alarms, control commands, failures, PDM, failure predictions, and maintenance recommendations. This is in very basic terms. This is how the ecosystem will look like. First layer, IoT connects equipment using sensors and communication network. For example, sensors measure temperature, vibration, pressure, motor current, energy consumption, flow rates. For example, a pump has vibrations and temperature sensors sending readings every second. And these, these send data to edge devices, gateways, cloud platforms, or on-premises systems. The second layer is the SCADA layer, supervisory control and data acquisition layer, where your they basically form an hierarchical network where the PLCs and the remote terminal units gather physical data and perform localized control, while HMIs provide local interface and SCADA provides enterprise-wide centralized oversight. Displays live process values, issues alarms where limits are exceeded, stores historical process data, allows operators to start and stop equipments, interface a PLC, HMI, and remote control units. This is the second layer. The third layer basically is your intelligence layer. Predictive maintenance uses historical real-time data and equipment when equipment is likely to fail. Instead of reacting after a breakdown, it predicts failure in advance. What the workflow will look like: machine sensors, internet of things, SCADA, predictive maintenance, AI, analytics, maintenance recommendation. The subset of predictive maintenance engine is install sensors, collect data, monitor equipment health, analyze trend, predict failure, generate alert, schedule maintenance, validate data. So this part of the workflow is basically the human part will also come into picture. Now, how do we get it started? Focus on assets that have greatest financial impact. Compressor, turbine, pump, boiler, CNC machines, and production lines, for that matter. Yeah, strategies that move. Now, this is the the aim with which we started. Yeah, our discussion today. The strategies to move OEE. Focus first on the assets with the biggest OEE losses. Yeah, bottleneck machines,
Mm-hmm.
equipment with frequent breakdowns or chronic micro stoppages. Monitor the right signals such as vibration, temperature, pressure, current, oil quality, cycle time drift so you can detect degradation, degradation early. Use predictive models to forecast remaining useful life or failure probabilities. Then trigger maintenance only when the data shows risk is rising. Tie alerts to work order process so maintenance happens before failure, not after a breakdown interrupts production. Combine predictive maintenance with root cause analysis and SOP updates so that the same failure does not return. How PDM improves OEE? Three channels: availability, performance, and quality. Yes, availability improves, fewer breakdowns stop the line. Performance improves because equipment run more consistently, and quality improves because worn components are replaced before they create defects. The relation between predictive maintenance and EBITDA, for that matter, uh, predictive maintenance improves EBITDA by increasing equipment availability, reducing maintenance costs, extending asset life, and improving production efficiency. Conclusion: predictive maintenance minimizes expected failures. Higher OE leads to improved productivity and profitability. AI and IoT enable proactive maintenance decisions. Successful implementation requires reliable data expertise and continuous improvement. Thank you.
Great session, Faisal sir. Uh,
Thank you.
I have few questions.
Yes,
Okay,
please.
so we'll spend another 10 minutes on the questions.
Yes.
So I have three or four questions. One is you said very nicely about the maintenance technologies, right?
Yes.
Different technologies. How? So how is that in the working in the real time? Like you said, yeah, this one I really like it. So you put
Yes.
some maintenance technologies. Uh, is this? I know the very large organizations they have a plan. Everything they will follow the process.
Yes.
The mid segment, yeah, to some extent, yes, they do it. That smaller organizations, how can they take advantage of this? Because as you said, maintenance is not an expense; it's an investment. Because
Correct.
the more you properly you do maintenance, your asset run long and do it
Correct.
properly. So it's an investment. It's not an expense. Okay.
Yes.
So what is your advice for the small and mid-sized segment companies? Mhm.
Basically, the small mid-size, they are still uh, in the preventive maintenance mode. Yeah, and I have seen in my recent experiences with while coming back to India, that some of these activities are being outsourced. Yeah,
Hmm.
yeah, ultrasound detection, vibration, oil and gas, thermographics. So they get outsourced, and to get, and to the 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 strength of the organization will lie in the fact that they internalize these things and do that investment. Yes. So I don't see that the small and medium organizations are still ready for it. They
Yeah.
still look at it as an expense.
Excellent.
Yeah, yeah.
Mhm. Good, good. So you talk very nicely about floating maintenance team leaders. Okay, that is very interesting.
Yes,
Uh, yeah. Okay, but that is something which is very important because maintenance should be taken as a very important function, and some seasoned leaders should be take care of it. Okay,
correct.
so yeah, how what I don't think it is happening in the organizations. Uh,
Yes,
yeah, what
yes,
is your
yes.
advice for this? Yeah.
Excellent point. You are basically touched all the key points here, Sheikh Saab. The good thing about your program is that you are very, keen listener. Yeah. The overarching maintenance crews is not necessarily available in the market. Yes, what we have is big maintenance teams where we have a maintenance department, where we have an electrical department, we have a workshop tool room guy, and we have instrumentation teams. Yeah. Now the challenge will be that how do you get maybe one or two professionals who are well versed with all the three scenarios, which is mechanical, electrical, and instrumentation. Now, what we have done in my earlier experience, and especially I have not seen that in the Indian context. Yeah, while I was working in India initially, but later life, in the last 10, 15 years in the multinational environment, they spend lot of time in training, and they have that what do you call it, the skill metrics, which is constantly being enhanced, you know and with a sense of urgency and a sense of need. Yeah, so we have people who can talk about mechanical, electrical instrumentation in the same spirit, and they can take charge of serious high level breakdowns that happen in the shop floor. Most, I would say, good 80% and a bit more than that are tackled by the machine operators itself. They have been trained as in the manner that they are able to fix the oil leaks, at least root cause them correctly, identify them correctly, communicate them correctly to the floating team maintenance crew. So that basically in itself is an assignment for organizations to train those people, because
Hmm.
if you look at some of the numbers that I was when I was preparing this presentation, I saw some US numbers and some India numbers. How much of these uh, losses we make as a country on an annual basis? They exceed in billions. Yeah, 150 billion, 200 billion in USA on the maintenance, bad maintenance, or lack of maintenance. So there is a definitely a deliberate need to look at department as a cost center. Yeah, and create that multi-skilling.
Yep. We lost you, Faisal sir, for 5 seconds.
Okay, yeah. So where was I?
So you are talking about multi-skilling, the cost center for the maintenance.
Yeah,
Okay.
so this is the multi-skilling is the training part of it. Yeah, identify the people with high energy levels. Yeah, my recent stay with Zuari was, when I went into that facility, I was tasked to create team leaders across all the SPE division, which is the sugar, power, and ethanol division. Yeah.
Hmm.
And when I walked in, I did not know this industry, and I was meeting these people for the first time. But during my 5 day of visit, I was able to identify those team leaders, which was like around 40, 44, that who will take the lead and build that kind of
Hmm.
dependency, the bench strength that the organization needs across various aspects of the business, which includes maintenance because it's a process industry, which includes safety, yeah, which also includes employee engagement. Yes. So people, the reason I am highlighting this is that every organization where you are working, people know who are where is the competence lying, and which is to be triggered to create that value, to create that sense of urgency, and building that bench strength.
Great, great. So one more question is, as you rightly said, there is a lot of optimization required from the industrial engineering side. So
Yes,
people, they start manufacturing units, they jump into lean bandwagon.
yes,
Okay, they want to optimize, they want to implement all those things. That's very
yes,
important. But
yes.
you have a fundamental gap in the industrial engineering part. Okay,
So
so
true.
when we traditionally copy Japanese
Yes,
techniques, but Japanese
yes.
techniques, Japanese companies have a very strong industrial engineering setup prior
So true.
to do the lean. So, what is your advice for the manufacturing units in this regard? Yeah,
Yeah. So you can hear me clearly.
yeah, yeah, yeah. Yes, yes.
Yeah, so basically, I keep revisiting industrial engineering for that matter is that I am basically a postgraduate industrial engineer, yes. And I started my career in the early 90s. And I spent about the first 6, 7 years, working as an industrial engineer. And when I came into outside of India, and I saw people taking more interest in the fads like business process re-engineering, total quality management, lean, Six Sigma, all of that, and with having no understanding or appreciation for industrial engineering for that matter. Yeah, industrial engineering per se talks about plant layout. It talks about human factors engineering, which is about building teams, training people, and it also talks about all kinds of seven waste, which is the material handling part of it. It talks about ergonomics. Yeah,
Processes. Yeah.
yeah, it talks about processes. Yeah, it talks about vertical horizontal communications. Yeah, so all the elements as a baseline that an industry needs are all present in industrial engineering. Now sadly, what I have seen, and I have tried to talk to senior people, is that they give a very stepmotherly treatment to industrial engineering in organization. They just bring in one industrial engineer and say he is the guy who will do the time and motion study or work study for that matter. So that basically defeats the whole premise of generating or creating that value out of that function. Yeah. So industrial engineering, for that matter, needs serious introspection, especially in the Indian MSCMEs, because a lot of industrial engineers who have migrated into alternate, roles, which is not uh, giving lot of value for the in Indian manufacturing, for that matter.
Great. Sir, Faisal sir, there is one question from, I think, posted in YouTube. Maybe it's a different type of question, but you can answer it. So I'll let me read it out.
Yes.
Usually, I go through every founder with one question. What is the biggest challenge you have ever faced in your first year? And how did you get first 10 customers or clients for your product?
Yeah. Yeah, so basically, if I understand this question clearly, and pardon me if I don't get it right, Being a manufacturing guy for that matter, I am a strong believer that get your house in order first. Yes. Now, once I have been debating this previously at many places, that which came first, a good sales or a good product. Yeah. I think a good product will always lead the way to a good sales. If you if so the thought behind this is that set up your shop floor uh, on the path of excellence, and then your sales order will fall in place. Because if you remember what happens in Middle East, for that matter, that any order which is big in nature, which is say 30, 40, 50 million, the client visits the shop floor. Remember, Sheikh Saab, the client will visit the shop floor
Correct.
and inspect your what procedures you are following. Do you have the legal part covered? You have the ISO documentation covered? How does your shop floor look like? What is your daily product quality? Where do you warehouse your products? All of that. So primarily, I will if I am a founder, I will spend all my time in setting up my shop floor uh, on the path of excellence. And we all know that excellence is not going to happen in 1 year. But I definitely put all the nuts and bolts in place and get the path and the direction right. And then which basically makes the life of sales teams, the sales manager, sales engineer much easier.
Great, great. I just add, Faisal Sab, it all depends on what kind of business you are in.
Correct.
Okay, so if you are, I don't know, because it all depends on the business. My advice is forget about first 10 clients. Okay, so first two clients or three clients are very crucial because that's early adopters. We call them as an early adopters. So they are the one who really trust and who want to do experiment with the new organizations, and they're open to take a chance and to get a better reward with the founders. Okay, so you need to identify them and then try to bring at least two, three good people. So that open the door for next 10 or maybe more. Yep, good, good. So I think any final key takeaways, Faisal sir? Mhm.
Yeah, we need to quickly move from preventive to predictive maintenance.
Preventive to predictive maintenance. I think
It's very
uh,
sensible. Yeah.
very
Very,
important, very important advice because
yeah.
it's ignored topic.
Yes.
Okay,
Yes.
everybody talk very fancy AI and everything, but maintenance is something which is very, very critical and backbone of a manufacturing industry. Okay,
Yes.
so thank you, Faisal Saab, for sharing excellent
Thank you. Thank
points.
you.
And ladies and gentlemen, give a big hand to Mr. Faisal Ziauddin. And if
Thank you
you
so
want to
much.
ask any questions, please keep posting it. We make sure that your questions are answered.
Definitely.
We have a limited time, 30, 40 minutes slots. So we want to get as much as possible with the speakers. So thank you very much, Faisal Saab, and
Thank
stay
you.
tuned for
So
questions.
nice. So
Thank you
nice.
very much.
Thank you so much.